Our project title is T3 Agent Tournament. We are a team of 3 members and myself Sindhu Bhargavi Kavashlapalli. In this project, we are implementing multiple tic-tac-toe agents in a tournament setting. This project aims to build an AI-driven tic-tac-toe game by using artificial intelligence. The game takes place on 3 by 3 grid and the played between any two agents at a time. Agent aims to win by forming a horizontal, vertical or diagonal line of all X or all O. The game is based on turn-based gameplay where each agent plays one after the other. The game ends when the agent completes a winning pattern or the grid is filled without a pattern. In our project, we are using AI strategies like Minimax, Alpha Beta Minimax, Expecting Max, and the Q-Learning. Our project objectives are all AI agents involved in the game are designed using different adversarial research algorithms or the reinforcement learning algorithms of AI. We are designing a total 4 AI agents, each acting as a players in the tic-tac-toe game. The user has flexibility to select any 2 agents to participate in tic-tac-toe game. The results of the game can fall into one of the following categories. Agent 1 wins against Agent 2. Agent 2 wins against 1. Tie between 2 agents. Coming to approach, each game outcome, win, loss, draw, contributes to the agent score. Win contributes positively increasing the score. Loss contributes negatively decreasing the score. Draw contributes neutrally no change in the score. Coming to Q-Learning, the Q-Learning agent makes moves based on the trained policy and the outcomes of the game contributes to its score similarly to other agents. And we are using Python 3 programming language. Coming to deliverables, a detailed user manual providing insights into the tic-tac-toe game implementation and execution can be found in readme.file. Algorithms developed for AI agent using Python programming language .py files. The entire project code, documentation and related files are accessible through the GitHub repository, and we are providing a YouTube demonstration project implementation and the slides. From here on, my friend Mallikarjuna continues.
Hi everyone. Evaluation methodology of the project here on goes as the code evaluates agents based on several criteria such as correct implementation of AI algorithms, stability and reliability, strategic gameplay, human-like gameplay experience, effective training. When it comes to correct implementation of AI algorithms, it explains about all the algorithms which were used in this project such as Minimax, algorithm, alpha beta pruning, expect max and Q-learning whether these are accurately implemented or not. And when it comes to stability and reliability, agents should provide a seamless gaming experience without freezing or failing. Strategic gameplay. Agents strategically aim to hinder the opponent's progress. When it comes to human-like gameplay experience, agents simulate human-like decisions and logical thinking. When it comes to effective training for Q-learning, Q-learning agents should exhibit effective learning and adaptation of the agents. The performance matrix is based on the number of wins of each agent and records the number of draws, computes and displays the average duration of the games. When it comes to agent scores, the final scores of each agent are updated based on wins, losses, and draws. When it comes to the average game duration, it calculates the average time taken for games across all played games. Yes, this code simulates a tic-tac-toe game where two AA agents compete using different strategies like min-max, alpha-beta pruning, expect-max, and Q-learning. The goal is to demonstrate how AA strategies make decisions and play the game optimally. The main AA strategies which are used in this project are minimax, alpha beta pruning, expect max, and Q learning. What does minimax mean? Like a basic algorithm that recursively explores all possible moves to maximize the current player's score and minimize the opponent's score. It returns the best move based on the exploration. So it always thinks about the maximum value for the current player and it minimizes the score for the opponent. When it comes to alpha beta pruning, it's an optimized version of the minimax algorithm that prunes branches of each search tree, reducing the number of nodes evaluated and speeding up the decision making process. When it comes to expectimax, it is similar to minimax but accounts for probabilistic outcomes, averaging the possible results when it's the opponent's turn. When it comes to Q-learning, a reinforcement learning algorithm where an agent learns the optimal strategy by updating a Q table based on static experiences such as state, action, reward, next state, etc. The agent can explore new moves or exploit known moves based on the exploration rate. From here on, my friend explains the code in detail.
Hi, myself Nitish. In our project, we have created code for tic-tac-toe game. The first, we have created tic-tac-toe game class, so which manages the game mechanics and rules. In that, we have created few functions init method. So initialize the game board, which consists of the 9 empty spaces, and then display board displays the board for the players. And we have created isWinner functions, which helps us to know which agent is winning. So you can get to know winning agent when there is a chance of getting these combinations. And there is also a chance of getting draw between two agents. So we have chosen isDraw function to get to know is there any possibilities of drawing with both. And then we have valid moves function. So returns a list of valid spots for moves. And the last make move function places the marker at the selected position. And next we have created the class agent. In that the main aim is to selecting the strategy for single agent or multiple agents. So based on the selection of strategy for single agents, we have min-max, alpha beta, expectimax, and q-learning. So coming to the min-max, so it recursively simulates moves and select the best one in that. So we have a function for minimax, so it will get into the loop and return a value from that. And next coming to the alpha beta. So it optimizes minimax with pruning to improve performance. So it also get the return value from that function. And then we have the third strategy, expectimax. So when there is a selection of expectimax, it evaluates move based on expected values, that is random outcomes. And the fourth strategy is q-learning. So it is about the reinforcement learning strategy where the agent learns from the past experience. So, and when we get into the play game method, so it simulates one game between two agents, so alternating the turns until one wins or the game is drawn. So in this play game, we are starting the game between the two agents. So we will get to know who is the winner and is there any chances of the draw. Actually, the code flow starts from the main method. So this is getting the input from the user like agent name or agent strategy so that they can when we selecting the strategy so it can move to the play game and it will move into the selection of the strategy function, so it will get return a value for that. When you're selecting the number of simulation games for each game between two agents, it will go into this loop and then it will run around 5 games. If you select 5 or more, so it can go into loop in that many times. And at final, we will get the execution time in for that. So when we coming to the output, so I'm running this code. So I'm giving the name for the first agent, and also I'm giving selecting the strategy for first agent as min-max, and coming to the second agent, I'm naming it as second agent, and I'm selecting alpha beta as a strategy. So then it's asking about the number of games to simulate. So I select 5. So it is generating the code and we have getting the mostly first agent as a winner. So we can get to know that winner is the first agent in the total game of 5 games. And thank you. This is our project.